Can everybody read that text at the back? Give me a shout if it gets too much. Okay, so I'm going to do a couple of sessions tonight. Start off with a general domain modeling thing and then look at collections, because link's quite an interesting thing in C#. I think it would be nice to see what the equivalent is in F#, because it's very different. I'm Ian Russell. A highlight of my sort of last few years is I've written a book. I've actually written an ebook called Essential F#. Its job is to get C# developers writing F#, less than 200 pages. It's a dead easy read. So don't worry about the code that I'm going to show tonight. Don't chase that or whatever. Just download the book and read it. That would be a much better use of your time outside of this. My job tonight is purely to show you some of the things that F# can do and to get you enthused. If it works, brilliant. If it doesn't, if it has the opposite effect, brilliant. At least you've seen it, at least you've got an idea, at least you're not working on, I don't know, rumour, supposition and all the rest of it. At least you've seen somebody who writes F# actually show some F# and give you an idea of what it's actually doing, because it is very different from C#. Normally at this point I'd apologise for dissing C#, because I will all the way through. But we don't do that anymore. We made an executive decision that C# is C#'s a great language. I've written it since 1.1. Sitting on a fantastic platform. If you like that style of programming, stick with it. It's brilliant. It's a lot better than the alternative. A lot of the alternatives, but I prefer a slightly different style, and hopefully that'll come through with what we're doing here. So a little bit about me. I actually lived here for nearly 10 years. I graduated from Sheffield Hallam University. Actually, when I started, it was still a polytechnic. So I think I did the first year. It might have been the first 2 years, and then they changed the name to become a university. So instead of having a polytechnic degree, I have a university degree. I'm actually a qualified teacher of mathematics. So I learnt at Collegiate Crescent, which is, I can remember it now, which is over by the Hallamshire Hospital, which the university sold off quite a long time ago, because it's fantastic building land. No doubt there's £1 million houses on it by now. So, but I live in Coventry. That's where I've been for the last 20 odd years. I started with Pascal, Turbo Pascal and VB6, and then picked up C# at 1.1. So that's in 2003. And I've been doing F# since probably 4.1, which is probably 2012, I think, something like that. Not all the time, but I have been full-time on F# for about the last 5 years. So as I said, my task today really is to introduce you to all these things. So first we're going to start off with is we're going to have a look at some of the building blocks of F#. So C#'s really simple. You've got objects, you've got classes, they have state and behaviour. And that should all work. You've got all these rules and regulations and principles and everything else that go with them. F# and functional programming languages are really simple. You get some data, you shove it through a function, and you get some stuff out at the other end. And that function could be lots of little things. So what we're doing is composing bigger things out of little things. That's functional programming. The rest of it, all of the immutable data and pattern matching and all the rest, they're features that make it nice and easy to do that, but they're just features. But the core essence of functional programming is data transformed by functions. And the data is actually really simple. We start off with tuples. So these are actually simpler than C# tuples. We don't have names for our items at all. So we don't have item 1, item 2, or whatever they're called now. I know you can have named items now, can't you, as well? So we define a type, so it's a coordinate, and it's a float, star float, so it means any float and any other float. Strictly that's not true, because if it's a GPS coordinate, there are rules and regulations around it, but we'll get to how to sort of solve some of those problems. So to create it, we use the let binding, we use a let keyword, so C1 equals 15 and 25. And then to deconstruct it, it's exactly the same as it is in C#. So tuples are the simplest of the. Obviously, you've got the general basics like string, float, all the basic primitives. But this is the simplest of the types. Anything above 3, don't use them. There are much nicer things to use. These are purely used for quickly handing bits of data off to other functions. You don't generally use them for anything else. So the reason why we don't do anything with tuples or tuples, depending on which part of the world you come from, is we have records. Now these are not records as they are in C#. So in C#, records are a nice little way of making a read-only class. This is not the same thing, it's completely different. So you've noticed it's the same words, it's a completely different thing, but it's a read-only type. And obviously it's got names. So I've got latitudes to float, longitudes to float. These are immutable. So once they're created, you can't change them. So F# is immutable by default pretty much all the way through. And this is when you create it, you have to supply all the data. So there are no optional parameters or anything like that. You can't add four of the items and not add the others. So you need to add all of that. So what I've done here is to create 2 instances of GPS coordinate. Note that I don't need to name it. The type inference has picked up that it is a GPS coordinate. I haven't clicked on compile, haven't done anything. The compiler actually works all the time. So if you write JavaScript, you write stuff from the top of the page going down, and if you try and use something down the page that hasn't been defined, you get a squiggly line. It's exactly the same in F#. It's also file-based in F# as well. So you don't see a project with alphabetically ordered files. What you see is random. Well, they're not randomly ordered files. They're correctly ordered files so that things are defined before they're used. It sounds wacky. Actually works really well because the compiler can tell you lots of things as you're going along. What I can also do is I can run the code as well by pressing Alt and Enter, and we have at the bottom of the page this little REPL. So rather than compiling it, running it, writing tests and all that, we can just try stuff out inside here. This is a script file, but I'd write exactly the same code in a proper FS file if I needed to. So I've created 2, and they've got the same data, and they're actually equivalent. So records use structural equality rather than non-structural. I'm sure I've forgotten what the term is now. Identity, whatever. Yeah. So they don't look at the memory space that you're pointing at. So they're just looking at if they look the same, they are the same. Okay. That's a record. So if I scroll down, now obviously if you do a bit of DDD, you'll find that when you get onto things like entities have identities. So you need to be able to compare them by identity. So what I've done here is I've got a record type called contact that's got a contact ID, phone number and email address. I'll come on to these things on the right hand side in a minute. And what I can do is I can override some of the behavior. So we can override equals. So everything you can do from a class type, an object inside of C#, apart from, I think, protected, and there's one other minor thing that you can't do as well, you can do in F#. So I'm not going to show you any objects-oriented stuff in F#, but F# does all the object-oriented stuff that C# does. So you can do interfaces, abstract classes, all that sort of stuff. So we override equals, and all we're doing there is we're doing a pattern match. We're comparing what's passed in. Is it a contact? So can it be cast as a contact? If it is, we get an instance of it, and then we compare. This in this case doesn't mean this, so it has no actual meaning. I can rename. I can rename it to something. It has no. It's not like C# or JavaScript where this has a very semantic meaning. It doesn't in this case. It's purely to do with we needed a name, and this is probably the most sensible thing to do. If you don't use the instance, you can just use a wildcard underscore. So it's quite obvious whether it's whether it's to do with the instance or whether it's just a bit of extra feature functionality that's added. So you need to do equals and hash code, and obviously got a built-in hash function there as well to do all of that. Right, so contact ID, phone number, email address. So most of the time we work with primitives, and we probably shouldn't, because primitives are too big. If you have an email address, the number of valid email addresses is a tiny fraction or a tiny percentage of the whole number of characters you can get into string. So what we do instead is we can build what they call a I don't want to use the word here, but I should do. It's called a single case discriminated union. It's just a very simple feature that allows me to say I can create an email address. So the type is an email address, and the data that's in there is an email address of string. So the second email address is actually a constructor. So again, I could change that if I wanted to. Oops. And we can see down here that where I was creating them, that no longer works because the constructor isn't set. Okay, obviously there's more logic that needs to go onto those. We'll get onto a bit more of single case discriminated unions later on because they're quite useful. So that's my record. I then create a contact. I create an instance of a contact, and I set some values. And then I can do copy and replace, which is the same. Obviously, it's slightly different syntax in C#, but you can do exactly the same thing in F# and have been since 2.1. Not that I'm bitter or anything like that. But. Okay, and then comparing the two again, because they all support structural equality. They're structurally equal. Not everything is structurally equal. So if you add a class type to this, obviously the class type isn't structurally equal. So you have to make it so that you can compare that in the same way. So we end up having to do this sort of logic that we're doing here for those particular types. So they're the first two types. So we've got tuples, which are really simple. They're and, so it's this and this and this, and then you've got records again, which is this and this and this and this and this, which is fine. One you won't have seen is we have something for OR, and this is awe-inspiring. No, sorry. Okay. So this is a discriminated union. So this something is one of these, or one of these, or one of these, or one of these. So we have a simple feature here. So we've got some eligible registered customers get 10% discount when they spend £100 or more. So we've got some simple data, some examples, and then we've got some restrictions as well. So eligible customers must have an email, optional for registered, no email needed for guests. So my first attempt is a record type. So I've got a name, which is string, email, option I'll come on to in a second, and then is eligible is a flag, which is Boolean, and is registered is Boolean. So we don't have null in F#. Actually, we do have null, as you're going to see in about 3 minutes or 4 minutes. But we don't like using null. You know, nulls. As long as you know what you're doing, null's okay. But what we tend to use instead is we use an option type, and the option type says it either has a value or it doesn't have a value. So the reason we do that is we're not surprised. So anytime we have something marked as optional, we have to handle that. Whereas in the C# world, you don't know until it blows up and comes up with a null reference exception that you actually need to go and handle it. So you end up defensively coding. So what we're doing is effectively we are defensively coding, but we're also explicitly stating this could have no value. So when you look at it, if you just see something that said customer, you wouldn't know if it's possible for it to be null or not. Obviously, some of the new stuff that's come into C# is designed to stop that in some ways, but you have to look at flags that are set and other things as well as to whether something can be null or not. And you've got these question marks, and did they bring the double exclamations in? I can't remember that they were talking about this. There's a load of stuff in there, but what they did in F# was they took a generic approach to it. So rather than having for every single type of thing that you could have, so there isn't a nullable types and reference types. They're just types. So you can wrap anything in an option. So there's one way of doing it, and that's it. So it says the email's optional. And obviously this is nonsense because it doesn't do any of the things that I want really. I mean, there's really silly things like it's possible to be eligible but not registered. But also, there's no way of checking that you can do the email stuff works or not. So that's probably not a good idea. We also have nothing in here that says anything about registered. It says nothing about eligible other than that flag, when they're probably quite an important thing within the business. Obviously, if they're not, then you don't need to do this. But in this case, they probably are quite important. So what we're going to do instead So what I've done instead is to write 3 records. So I've got an eligible registered customer, where they've got a name and an email, a registered customer with a name and an optional email, and an unregistered customer, which is a string. And to use that, what we have is we have a discriminated union. So it's a customer. They're either eligible registered customer, or registered of registered customer, or a guest of unregistered customer. So there must be one of the 3, and that's it. So what are they not like? They're not like an enum, because you can put arbitrary data on these. So these have got one piece against each one. You can have as much data as you like, or you can have no data against any particular item. So they're not like an enum from that perspective. They're also not like an abstract class and concrete instances. They look like they are in some ways, because you've got customer, which is the abstract class, and then you've got the concrete instances, but you create concrete instances, and that's how the compiler works with it. For you to work with it as an abstract class, you actually need to tell it, I'm going to use this as an abstract class. No, I didn't put that quite correctly. So say you wanted to pass the customer through to a function. you wouldn't pass, you could easily pass any of those three items if they were their own, if they were real types. These aren't real types. What you're passing through is the customer to each one. So they're not like concrete instances. They are real, but they're not real. So you pass them around as customers, and then you have to pattern match to work out what they are. So it might be easy just to show you how it pans out. So I've created 4 customers, and if you look on the right-hand side, that's the compiler telling me that they're all customers. Despite the fact that the top 2 are eligible registered, the Richard is registered, and Sarah's a guest, they're still recognised by the compiler as a customer. So let's do a little bit of little function. So in this case, we've got curried parameters, so they're individual parameters, a bit like Python. So not like tuple parameters, which you have in C#, where you've got the commas between the bits, and you need to split everything. We can do nicer things with this. So we've got calculate order total, so pass in the customer and spend, and notice the compiler has worked out what my types are. So I haven't had to do anything to do this. It's pretty good. If you're just writing F#, it will pick them up probably 90% of the time at least. Sometimes you have to override it. Sometimes when you're dealing with framework code, with C# framework code, when you've got overridden functions, overridden methods, obviously we have no way of telling which version of the overridden method you wanted, so you might need to express one of the types at that point. So we've got a little function there. We then work out what the discount is. So we do a pattern match. So we match the customer with eligible. The underscore is exactly the same as you'd use in C#, so it's a wildcard. We're just not interested in the actual instance. And then we just return the value. There's no return keyword in this. We do use return later on, but not for this. There's one very specific area that we use that for. And then I can quickly write some assertions. Obviously, I could write proper tests if I wanted to. So if I highlight code, run it, see it's run in the background, and I just will do all these. Okay, so they're all true. So when we're trying stuff out, we tend not to write tests. What we tend to do is to do everything through this first. So we are writing tests. And the idea is that if we write these properly, we should be able to take these across into XUnit or whatever, into a separate project and run them as tests. But it's just our way of trying stuff out. So it's very quick and easy to work with. Everything's in one file, and it just saves no end of time. I'm not compiling all the time. And if I make a change, all I need to do is change run the bits of code that I've changed. So I don't need to run all the code again.
If that's part of the project, do you leave that stuff?
The script file, this never gets compiled.
It's never getting compiled.
Yeah, so you can have in a project, you can have a load of FS files, they'll get compiled correctly, and you can have scratch files like this, and they can stay in there if you want. They won't get compiled, all they'll do is stay with the source code. So that's those. So we've done tuples, records, discriminated unions. So we had 2 AND types, and now an OR type. That's basically it. We don't need much more. It's amazing how much you can do just having those 3 types available, and you can combine them any way you like. So you can have discriminated unions. You can have discriminated unions inside tuples. Quite why you want to do that, I don't know, but you could do. So yeah, so they're very simple. They're very simple concepts, and all we're doing is pushing these types through functions to get answers at the end. So I haven't created 10 files. I haven't had to compile every step. It's a very easy flowing thing. I know this is quite noddy code at the moment, but actually what you end up writing is pretty much this all the time. So it might seem very simple, it might seem very simplistic, but actually this is the sort of thing you do all the time.
What happens, so you've got your data you've declared as in code there, but what if you wanted to, obviously like in a production system you're not writing the data in the code, so how well does that work when it's loading data from a database? So they're like ORMs that support that, or do you have to write a lot of code so that when you read in a record from the database it gets created as the right kind of...
It depends how you store it. So Entity Framework is designed to work with classes, and it's designed to allow you to do things like the multiple concrete classes over an abstract type, and you can actually tell it to save it in that way, and it will undo it. Obviously, we don't use Entity Framework because it doesn't work with F# at all. It wasn't designed to work with it. There are ORMs, there's things like Dapper and stuff like that. Again, it's down to how you decide to store the data. You know, if you store the data in something other than SQL, you know, you can store it how you like. But there's no, you'll know yourself if you start doing, the more complicated you make things, the harder it gets. What we tend to do is we tend to stick with the more complex structures in the middle. So if you imagine, we treat most of it as being DTOs from the outside, complex stuff in the middle, DTOs going out. So yes, we would write some form of factory that would take the data and then create the instances. So yes.
That's it.
Yeah. So yeah, I mean it's there isn't an ideal solution. You know, if there was a you know, if there was a, I don't know, it's there's no such thing as a perfect database. You'll always end up with how you store the data depends on how you want to get it out. So so a lot of people are moving to things like CQRS, or event sourcing from that, and having projections to get the data out. So lots of people are writing those things all the time anyway. So, but it depends on how complex you want to make things. My suggestion is always you make the middle bit as complex as it needs to be, because that's where the business value is. The rest of it is just get the data in, get it transformed in the safest, quickest way. Get it in, do what you need to do with it, get it out. Same thing.
So presumably with something like that, you could almost store those in a single table.
Yes.
And then just use factory just to create which one of those customers you want.
Yeah. I mean, we were using Postgres, and we're actually storing this as JSON.
Yeah.
So we were storing quite complex structures in JSON, and Postgres allows you to query on JSON. But it depends on your data. You know, we had lots of data that was amenable to that style. Not everybody has that available. You know, this isn't a silver bullet. There is no perfect way of writing code. You know, if there was, we'd all go to the same university. We'd do the same course. We'd have you know, it'd be a profession. You know, because we could measure people against others because you'd all be doing the same things. But it's not. You know, it's what's the least risky approach to take, rather than the other side, which is what's the nicest way of doing it. So if I can, yeah.
So back to that being a script file.
Yep.
Presumably you then lift some of that out and put it in a permanent sort
Yep. Or you rename the file as a .fs file.
Or you
Just rename the file as a .fs file.
with all like your asserts and stuff, your tests and stuff in this.
Yeah, you can comment those out if you want. But yeah, it's you tend.
Are they doing it? If you leave them in there, does it matter?
No, most of the time you just get rid of them. You've got source control anyway, so you can always get back to them. Right, so one of the things we looked at earlier was single case discriminated unions. Right, so a single case discriminated union, it's still a discriminated union, but it's one of them rather than having multiple options. So if I move the mouse over it, you can still see that it's a union. There's a bar there. You can add the bar if you want to, but it doesn't actually matter. You notice on the one below it, with the validation error, I've got the bar there, because that's not intended as a single case discriminated union. That's actually intended as a standard discriminated union, where I add other error types into that. Whereas this is very much intended to be just a single item. Now, with it being a GUID, there's not a lot I can do, really. You know, you create a new GUID. There's no. I suppose I could check to make sure that it's not an empty GUID, but it doesn't support nulls. It's a struct, so so there's very little you can do with them anyway. But that's not true of everything. So if we go and look down a little bit further, I've then had a look at spend. So obviously with spend, the idea is I can create a spend by using the constructor and putting a decimal in. By putting private in, what I'm saying is you can't create it that way. And what we do instead is we create a module with the same name as the type. The required qualified access means that I can't just call these functions. I need to say module name dot function. So the module name is pretty much like a namespace, but it's an F# specific one, so we can have attributes like required qualified access. So in this case, I'm saying I want the value of whatever comes in, a spend. So that's my spend. This is called a forward pipe operator. I seem to have lost my my fancy graphics. Oh well, I'll sort that out. So that's a forward pipe operator. What that does is it takes whatever on the left-hand side and puts it at the end of the next line. So here we've got this is an anonymous function, just the same as you can do in C#. So what this does, but it's obviously fun rather than func. Maybe that was fun C#, I don't know. But this is so this is fun. So what this is doing is passing input into the whole of this. So that's an anonymous function, and it's deconstructing that thing and then returning the value from it. Now create, I've decided that there are limits on this, so that it needs to be between 0 and 1,000. And if that's okay, then I'll return a specific type called a result type. And if it's not, I'll return an error from that result type and tell you that you can only return certain values. So in F# and C#, functions take one input, return one result. That's it. Now, obviously, in C# and in F# as well, you can you can raise exceptions. So technically they're not telling you exactly what they do when you look at function signature. So one of the things that they've tried to do with functional languages is to try to make them more transparent about what they're doing. So rather than raising an exception for everything, what we do instead is say, is this actually an exceptional case? Or is this something we should know about and we should be able to handle? And obviously if you're connecting to a database and database connection goes down, that's an exception. You know, you've got things like poly to retry and all that sort of stuff from there. So that makes no sense wrapping that up. But if you've got a business decision that says the input value you've sent in is outside the range, you shouldn't be throwing an exception for that. Because it's not an exception. It's a known rule. So what we do instead is we return the result type. So the result is like this. This is actually built into F#. Result is a discriminated union. It's a generic discriminated union, so it's OK of T success or error of T failure. So it's one of the two. Oops. Right, I'm back. So if it's successful, then it's an OK. And if it's a and if it's not OK, then it's an error. So when we look at the signature for this function, this create function is a decimal to result and a spend and validation error.